Please excuse the temporary change of environment. I'm not back at my normal bench yet, but I will be back at the bench in the future. While here, I've been digging out other stuff and found this old ozone generator. Now, this ozone generator had two functions. It was either designed just as a sort of room or space ozone generator, or you could clip a little housing in the front that had two pipes, two flexible pipes that you put into footwear. And then it has a 12-volt supply, and you can either choose a single pulse, single shot mode where it will just run for a certain length of time, or you can choose continuous running just for as long as you want, then turn it off. But when you turn it off, well, first of all, this overrides that. So I'll unplug this and see if I can reset that. Plug it back in. No, it's not reset it. Right, tell you what, I shall have another go. It's a quirky thing because it's not based on microcontrollers. If you turn this off, it doesn't just shut off straight away. It does this thing that it ramps down slowly. Can you hear that? The fan is slowly ramping down. And then it shuts off. Okay, let's pop the lid and explore it. So inside is no, I've just hit the button. Inside is an air guide. It's got a standard computer style fan at the back, and then it's got the ozone generator with its high voltage supply down here. They have scrubbed the number off the chip, which I'm going to guess, and we'll deduce this. We'll take a look at it. I'm going to guess that's a 555 that they've done that to. I'm not sure why they've gone to such secret degrees, but anyway, we shall explore it. The ozone tube is a dielectric barrier tube. It's a glass tube with a conductive coating inside and then a bit of mesh outside. And because it applies high voltage AC across it, and because it can't arc through the glass as such, you get capacitive coupling, and where that capacitive coupling occurs onto the mesh on the outside, it creates a slight purple discharge, and that is the ozone, what generates the ozone, the corona discharge, and then the fan blows the air across that. Let's unplug this. Underneath this is the control circuit board. Oh, I can unplug that. I shall unplug that. And the control circuit board has, let's unplug everything and get my little magnifying glass in. KA555. So it's using a 555 again. I'm going to guess that might be part of the automatic shut-off circuitry. And when you push the button, it probably triggers, it charges a capacitor, and then the capacitor slowly discharges until it cuts off. Lots of transistors. I don't really have the facilities here to start reverse engineering this, so I'm just going to be exploring it. And to be honest, the circuit board I'm most interested in is this one, the one they're being all secretive about. We don't like it when they keep secrets from us. Let's take some screws out of here. So there's 4 screws in the vicinity of the ozone generator tube. This is kind of old hat these days. I used to use everything out of desperation. I had stinky feet. My work boots used to really stink, like really offensively stink, and the cure, it turned out, was boric acid, fine powdered boric acid, or not fine powdered boric acid that you've sprinkled into a put into a coffee grinder or something like that and turned it into fine powder. So what do we have? There's a transistor right next to the high voltage transformer. I don't think I'm going to get a zap off this. I shall finger everything and get any shocks over with. No, that's fine. We've got the ozone generator thing, which has one connection going up to the end. This is very messy underneath. Very messy. But they've got this loop of wire that holds it up also connects onto the outer mesh here. And this central connection is going inside. And the glass is cracked here. Doesn't really matter. Although it could, technically speaking, arc through. Or is that just resin? I'm not sure. I think the glass is cracked. It doesn't really matter. But that has the conductive coating. They've put a conductive paint inside to provide a continuous conductive layer inside of that tube. This is the fairly standard high voltage transformer with the core and the winding in the middle. It looks as though it's only going to be 2 connections because the transistor here is actually doing the switching of that. And I would guess that transistor is being switched from pin 3 of this chip, which is going across here and through a resistor and through the transistor. That is exactly what it is. This is just a 555, the one number that the chip that they've scrubbed the number off. How strange that they've gone so secretive. And they've got a facility to fine-tune the oscillator to match the transformer, and that's what ultimately generates the high voltage. Interesting stuff. Let's take a look at the other components in here. This is quite a complex little circuit board. It's also held in with an excessive number of screws. Far too many screws. I think they were trying to be serious here. I shall also pull off the power connector. And I'll see if there's any clues in the bottom of this, but it's a single-sided board. It's quite densely packed. It's got 1, 2, 3, 4, 5, 6, 7 transistor-like things, and the 555. One of those transistors will be switching the... well, the transistors may be being used as latches. Not really sure. It's a very densely packed little circuit board. That would take a bit of tracing through, and it's the sort of thing that not only would it take a while to trace through, but I'd have to basically take a photo of both sides to actually facilitate tracing that. I'm not that keen on doing that though, because it's kind of old-fashioned. I know it's nice that, you know, it's not microcontroller based, but it is just... it'd be a pain in the arse reverse engineering that, quite frankly. And it's just a crappy old item anyway. It's kind of out of date. These days we'd use a different approach for generating the ozone at sort of low levels. Or we'd use the little ceramic plates, which use the same technology, but not this sort of clunky old tube-based system. This is just 2 resistors, 3 LEDs and 2 switches. One of which is latching, and the other, the momentary one, for the triggering, the controlled cycle, just doing a single press. It's non-latching. The fan is rated, it says, DC 350 milliamps, which is quite powerful actually. But that's it. That's what's inside this. It's very retro. It's kind of does its job, I suppose. I kind of used it for a bit, but I didn't really use it an awful lot. It wasn't that great. But certainly it was probably more fun just taking it to bits than any of the use of it. Bonus extra footage, I have reversed the high voltage section. And the reason it was looking so terrible in the back is that past Big Clive has obviously had a go at this because things have been marked and coils have been drawn on. So I have reverse engineered this in the past. But nonetheless, I have reverse engineered it again and found something quite funny. So it is based on, I'll just sweep all the dust off here. It is based on a 555. They've gone to great lengths to paint over all the numbers on the capacitors and resistors and also scrub the top off the chip because this is their super secret circuitry. It's not that secret. The 12 volts comes on. Here's the common 0 volt rail. 12 volts comes on, decoupling capacitor and smoothing capacitor. And then there's a little inductor for reducing the passage of electrical noise, and then another smoothing capacitor. And it's worth mentioning that the same circuitry as on here, the main control circuit board, has the power coming on. It goes through a polarity protection diode, electrolytic and decoupling capacitor, then the little inductor, and then more electrolytic and decoupling. They've gone to great lengths to keep the power clean. This 555 is directly controlled from the switch, by the way. When you trigger this one, it is introducing a single step delay, but the rest of it is just the transistors are for switching the loads or level shifting or buffering as Darlingtons. It's actually very, very straightforward, but that's not the bit we're looking at. We're looking at the high voltage section, which is based around the 555 classic. I believe it's the A-stable configuration. Is that right? I think it is. And they've got the usual resistive divider here. One of them is a variable resistor, so they can tune the output speed of the 555, the frequency, to match the inductive load, the transformer. Things worthy of note, the pin 5 should normally be coupled to the 0 volt rail with a capacitor just to provide internal stability. They've not done that. They probably just didn't think it was needed. I don't know what value this capacitor here is. I've just said nanofarad because that's what it's going to be probably. But this then puts out a roughly square-ish wave. The mark space ratio would depend on this setting here, through a 680 ohm resistor to a Mosfet. The Mosfet is an IRF234N, really common Mosfet, and it switches the primary of this transformer. That has a little capacitor across it, presumably as a tuned circuit, also potentially to clamp any sort of spikes when this turns off, although there is inherently the diode built into the Mosfet for that. That then steps the voltage up to the secondary, which is referenced to the 0 volt rail and has the dielectric barrier across it, which then generates the corona discharge in here that the air blows past, and that creates the ozone. And it is quite funny that I saw that cracked glass and I didn't twig at the time, but the mesh round the outside, they've actually seen it. It must have maybe arced in the factory through that crack, or they saw it. They've taken a red Sharpie and they've marked the mesh round and they've cut the mesh clear of the crack so that it does work. I don't think it would have been me who did that. I think it was probably them. But there we go. That is it. So that's the bonus extra. You get the high voltage circuitry. The rest of it is just fairly textbook, either straight on, off. Odd that they've separated the fan and the ozone generator so the fan runs on a little bit. It might just be a little gimmick to actually purge air through to make sure there's no ozone left in the unit. But I don't think so. But the rest of it is just basically level shifting and stuff like that. It's not that complex. But that is it. The circuitry of the ozone generator for sterilizing footwear as reverse engineered.